Now let's go in depth into codecs. First, bitrate. Bitrate is file size. If you increase bitrate by 2 times, your video file will be 2 times bigger. If you render 4K instead of 1080p, but you don't increase the bitrate, then video file will be the same size. More bits means codec can manipulate with more original data. Less bits means it will aggressively try to reuse the same data and thus create artifacts such as macro blocking, banding, or just loss of detail. We have 3 methods of assigning bitrate. First is constant bitrate, which means every second will give the same amount of bits to work with. Second is variable bitrate, in which bitrate is dynamically assigned on the fly. More to more complex scenes, less to less complex scenes. It is commonly used together with 2-pass encoding, which means it will first analyze whole video and then encode based on findings. By doing so, it knows what happens ahead of frames that are currently processing, and it can assign bytes more effectively. Third method is constant rate factor. This method is completely different because it is adjusting the quantizer based on scene and motion. It's used to maintain visual quality on some level and completely ignore bitrate. This means that one video can have 20 megabit average bitrate, while another one can have 7 megabit average bitrate. So when you should use these 3 methods? Constant bitrate has the worst visual quality because it never saves bits on less demanding frames or scenes, so it shouldn't be used if you want efficient encodes. Variable bitrate is the best choice when you need predictable file size, like on constant bitrate, but you will get better quality or a little bit smaller file with same quality compared to constant bitrate. This is the best choice for majority of online use cases, such as uploading video to your own site or live streaming on any site, unless the site requires constant bitrate. Constant rate factor should never be used for online use cases, as it's completely unpredictable and you are working with predictable limits, such as internet speed. This unpredictability is useful for storing video files offline, however. If you want to transcode all of your videos to save on disk space, CRF will save most space while maintaining the visual quality that you need. I also use CRF for uploading videos to YouTube, because I don't need predictable file size, but the lowest possible file size that I need to upload. Presets. Every video codec has presets. These are limiting how many features an encoder can use. Faster presets means less features, and most of the time existing features will have less resources. Because of this, faster preset will encode way faster, but quality to file size ratio will be way worse. That also means you should use this lowest possible preset, but what is possible differs depending on what you are doing. For live streams you are limited by real time, but for something like VOD encoding, you can spend 3 hours to encode one video. Also remember that if you want to have faster encodes, for example if you are publishing news to social media, then you can speed up encoding by going with faster presets, and you can maintain the same visual quality by boosting bitrate or decreasing the CRF number. It's all about the ratio between speed and efficient size. But how you can find out which preset, bitrate and codec combination will be the best for you? There are a lot of tools that you can use, such as SSIM, PSNR, but the golden standard is VMAF. VMAF is a perceptual video quality assessment algorithm developed by Netflix. It sounds like a very advanced thing, and it is advanced, but the results that you'll get are straightforward. You need to input both original or uncompressed video and compressed video. Based on these 2 inputs, VMAF will give you a number. Higher number equals less visually noticeable difference between 2 inputs. I said visually noticeable because VMAF isn't just comparing bytes to bytes, but rather compares video based on human perception of vision. This algorithm is amazing. Now I want to show you a tool that will help you with everything I just said. AV1. This program will give you VMAF results, predicted file size and predicted encode time for your settings by sampling a couple of frames from the original input. Yeah, you don't need to encode your videos at all bitrates, CRF settings or codecs. You can just use a couple of commands to find out the best combination. This program has AV1 in name because it was first designed just for AV1, but now you can use more codecs with it. Here is a simple script that I made. Results will tell me how bigger the file needs to be in a faster preset if I want to maintain the same visual quality. You can do it not only with AV1, but also with H.264 or H.265. I've already used this program for download feature in VOD site, and it helped me a lot to get acceptable visual quality at lowest possible file size for offline playback. Which VMAF number is acceptable or good enough depends on your expectations, but I've decided to go with encode that has at least 88 points on 720p video. 100 is the maximum, and most people decide between 86 to 96, depending on what they are trying to achieve. Remember that visual artifacts are more noticeable at lower resolutions, so a VMAF results of 88 on 480p will have more artifacts than 88 on 4K. And you can learn more about that in VMAF frequently asked questions. With these results, you can make an encoding ladder. Encoding ladder is a great piece of information for you, where you will quickly find out which encoder settings combination is the best for what you are trying to achieve. You can also find some other encoding ladders online if you want to find out which is the best combo for other people. Now, there's one big thing that we need to talk about. You can encode with software encoder or hardware encoder. Software encoder will work on every CPU, but for a hardware encoder, you need it in hardware. In all modern PC systems, you have such encoder built into your graphics card. But there are also media accelerator cards that are used by biggest networks or biggest livestream sites. In this video, I will focus on GPU encoding. So which is better, CPU encoding or GPU encoding? For visual quality, CPU encoding is always better, as software encoders can update. They are not limited by memory because you have way more RAM than VRAM on a graphics card. And also, graphics card is graphics card. If encoding block wouldn't be simple, then it would be very expensive for AMD, Nvidia or Intel to have it on GPU. So, encoding block on GPU may be simple and cheap, but your graphics card and VRAM isn't slow, and because of that, GPU encoders are blazingly fast. You can encode hundreds of frames per second even on cheapest graphics cards. And because of that, if GPU encoding is good enough for you, then efficiency is just amazing. You can have 20 encodes at once with one cheap GPU. And if you would want to do the same on CPU, then it will be very expensive to build such server or cluster of servers just to have the same throughput as some $150 GPU, but it's like 50 watts. Just remember that if your CPU has good enough throughput for your work, you should never use Nvidia, AMD or Intel encoders that are built into your GPU, because they have worse quality, especially at low bit rates. In the next part of this series, I will teach you more about audio encoding for videos and also give you some recommendations and tips. Go watch it right now.